Alright, continuing on with section 1, relative extrema. And this is going to be problem number 7. Move my mic a bit, okay. Yes, there's a mic here, in case you were wondering. Alright, so we've got a derivative. F prime of x equals x plus 1 times x minus 3 squared. The critical values are -1 and 3. Right, the values at which the derivative equals 0 are -1 and 3. And now we have to examine the intervals between them and on the left and right side of them in order to be able to sort of examine the behavior of the curve in relation to these points, and thus be able to identify if these critical values are indeed extrema, relative extrema. So let's do that. So let's set up a little chart here. We've got -1 and 3, and so between them we have an interval -1, 2, 3. And then after 3 we have an interval 3 to infinity. And then before -1 we have -infinity, -1. And we have two components of the derivative. We have x plus 1 and we have x minus 3 squared. So we're going to want to again look at whether the derivative is positive or negative in these intervals on opposite sides of the critical values, and then that will give us that will basically tell us whether the function at these points has a relative maxima or a relative minima. So f prime of x. Alright, so let's examine the first one. So anything less than -1, so let's pick -2. -2 plus 1 is -1, so that means this component is negative. -2 minus 3 is negative. Squared, though, that's going to give us a positive value. And so a negative times a positive is going to give us a negative first derivative, which means that the function is decreasing. So it's going down to -1. I'm like fine-tuning these tables as I move along. The first one was kind of a mess. I apologize for that. Anyway, so now we're going to figure out, what's the curve doing between -1 and 3. So let's throw in 0. 0 is always an easy one. So 0 into the first component is going to give us a positive value, and 0 into the second component is going to give us so we have -3 squared. So that's going to give us a positive value as well. So a positive times a positive, that means that the derivative is increasing in this interval between -1 and 3, and thus I already drew all my conclusions before I stated thus. Anyway. Alright, so now we want to figure out what is the curve doing after 3 and to infinity. Like, what is its behavior? So let's plug in 4. 4 plus 1 is positive. And then 4 minus 3 is going to give us 1, which is positive as well. So the curve is actually increasing from 3 to infinity as well. Alright. Let's examine the nature of these critical points. So, -1, the curve is decreasing before we get to it and increasing after we get to it. That means we have a relative extrema, more specifically, a relative minima at -1. So -1 equals a relative minima. And well, let's just call it relative minimum just to be more precise. And for 3, we see that before 3 the function is increasing, and after 3 the function is increasing as well. So here we have a situation where we have a critical value that is not a relative extrema, because the curve does not change its behavior in terms of its derivative before and after. It continues increasing before and afterwards. So 3 is not a relative extrema. And that's it. We are done.